Hi, this is Phil Boyer. I'd like to show you how to use an Excel spreadsheet as well as Google Earth to plan a trip. And this could be for anything from a canoe trip to a boat trip, car trip, whatever you want. I use this for planning my solar electric boat trip up the Rideau Canal system when I went from Kingston to Ottawa and then back to Perth. Um, So starting out, you open up a spreadsheet and you first need some data. And so you can see here I have all my destinations along the way. I have them listed. Start from Kingston Marina, then first set of locks at Kingston Mills, second set of locks at Lower Brewers, and so on. Lakes along the way. This would be day one into day two, and you just keep on doing that until you have every destination that you plan to pass by on your trip. Then the next set of data you need is, of course, what is the distance between each of those points? So from my starting point at Kingston Marina, to my first destination, Kingston Mills, 7.75 kilometers, then 15.93 kilometers to the next destination, and so on. And you could tally it up at the end of the day of how far you are going. So those are the first things you need to do for your spreadsheet, your destination and how far it is. And if you don't know those data points, you could figure that out. And I like to use Google Earth. I find this to be a fantastic tool to use. And here you could see a close-up of Kingston and the Cataraqui River starting up the canal system. And so I'm going to start right here at the Kingston Marina. Now, for Google Earth, this is on the downloaded version of Google Earth. And you go to the Tools menu, select Ruler. I select Path. You could select Line, but I like Path better. And whatever you want to measure it in, and I like to use kilometers. And just move that out of the way, and I'm ready to go. So I could zero in on the Kingston Marina, just click on that to get going, and I just work my way up the whole canal system. Now, if you need to zoom in, like if you have a narrow part of the river or wherever you're going and you need to zero in, I could zoom in, and that doesn't affect the calculation for distance at all. I could then proceed along, and as I'm getting closer, I might want to zoom in. Oops, got that a little bit off. And you could just drag your data point back to where it needs to go, and then continue on until I get to the locks. And you can see from this 7.23 kilometers. If I was to go through the locks, you're adding to it. So also the more detail, the more you zoom in, and you could get a more accurate view of your trip. That number might change a little bit, but basically it's 7.25 kilometers. So you would do that for all your destinations along the way. The other nice thing is with Google Earth, I could now zoom in on this location, and I could get a good look at the lock system. I can see that there's 1, 2, 3, 4 sets of locks that I have to go through, and I have to be aware of that for my timing, because that does take time. Takes time to get through, depending on the traffic. Could delay you by an hour hour and a half, 2 hours. You don't know. Anyways, I will close that down and back to my spreadsheet. So there's my first data point. I use 7.75 kilometers, and I populated the entire row with those distances. Now my destination for the end of day one was to get to Jones's Falls, and you can see that's 44.46 kilometers, which is a significant distance to go in a solar electric boat with a displacement hull. But that's my destination. You'll see in the next column I have my speed, and right now I have it set at 7.5 kilometers an hour, and each one of these cells points back to this variable right here. So if I was to go in and change that to 6, everything else changes to 6. I'll go back to 7.5 for now. And of course, with the speed and with the distance, you could calculate your time it takes you to go that distance. And just using a simple formula. If you've never used an Excel spreadsheet before, then you might have to watch some tutorials on Excel spreadsheet, but just very simple formulas. The next data point I had was my motor current. Now this is the current that's being drawn out of my 24-volt battery bank that the motor requires to run at these different speeds. So at 7.5 kilometers an hour, it basically draws 16 amps out of the battery bank. Now the interesting thing is, on a displacement hull design, your current changes dramatically with your change in speed, exponentially. If I'm traveling at, for instance, at 6 kilometers an hour, I would only be drawing 8 amps out of the battery. If I was to up that to 9 kilometers an hour, I'd be drawing 29 amps. So very dramatic change in amount of current you're drawing with your speed. So you have to kind of figure out what your ideal speed is. And I'm just going to go back to 7.5 for calculation purposes, and I'll set that to 16. This solar current is in column H, and this is the amount of current that I'm generating through the solar panels, and it's actually going back into the battery bank at 24 volts. Excuse me. Right now I have it set at 12 amps, and I'm picking 12 amps as kind of an average for the day. So over a 6-hour period on a nice sunny day, if I'm traveling in the afternoon, morning till afternoon, I would probably average about 12 amps. This could peak up to 18 amps. It could be down to hardly anything, etc. But you have to kind of figure out an average current you're going to be using. My net current is the result of what I'm drawing out of the battery bank to what I'm putting into the battery bank, and that leaves me with 4 amps at the end of the day. Amp hours used. Well, I start with a fully charged battery bank of 221 amp hours. At the end of the day, after traveling 44.46 kilometers, I'm calculating here that I would be using about 23.71 amp hours. And that's based on if these theoretical numbers are exact. And of course, there's so many variables you'll see during the day that things change. But what this tells me is what is my state of charge at the end of the day. I started at 100%, and in this scenario I ended up with 89%. With a lead acid battery, you don't want to draw this down below 50%. That starts to affect the life cycle of the batteries, and that, so it's very important you keep your batteries well charged. And the other thing is, I'm finished day 1 and I'm at 89%. Well, to start day 2, I don't want to start at 89% because then I will deplete it even further, and so on. And I need to recharge the batteries at the end of the day up into, if not 100%, maybe into the 90% range. So that's kind of my goal for the end of each day. Recharge time. Now the other thing you got to remember is if you draw 10 amps out of your battery bank during the day, 10 amp hours, you're going to have to put that 10 amp hours back into the batteries, and that takes 1.5 times longer than it does for discharging. So I end up with kind of I have a total hours scenario here where I'm adding my recharge time plus my traveling time. Now luckily the recharge time can also be as you're stopping along the way. For instance, I'm at the locks. Well, I'm just sitting there idle. Well, that is recharging the batteries as I'm sitting there and going through the locks, as long as I'm not in the shade. So at the end of the day, I have my destination I have to get to. That's number 1 on my list. I have to make that destination. And also at the end of the day, what's the state of charge of my batteries? So those are my 2 things that I'm concerned about for my trip. If I have to reduce my speed along the way to control my current, I'll do so. And if you've watched any of my videos on my my actual trip up the Rideau Canal system, I call this current management. So I'm always juggling around my speed to, if I think my state of charge is in danger of going too low, I will reduce my speed, and it makes for a longer day, but at the end of the day I need to have the batteries charged up. So I continue that scenario for the entire trip, and going down to day 6, where I actually reach Ottawa. You can see that it's a short day in the morning, and of course day 6 is split, and I actually start my trip back and that. But I just do this for the entire trip, and I could go in and change the scenarios as I want before I take this trip, to run through theoretical issues that I might encounter along the way. For emergency purposes, I've put in here different lock sites that have power available if I need to stop and plug in and recharge my batteries. I could do so, but I would only do that in emergency purposes only, and because my goal is to do the entire trip strictly on using solar power for charging the batteries. Using the Excel spreadsheet, that's on page 1, you could put another page in here, and you could put in a PDF drawing of the map, and I've done that. So you could have a lot of information in your spreadsheet just by using different pages. Another interesting chart that I found for this trip was a water level chart. This shows all the different water levels that I would be encountering as I went through my trip. So here it's at Kingston. Now the first set of locks I get to is Kingston Mills, and you can see all these little steps. Each one of these steps is one of the locks. And so there's 4 locks there. When I get to Lower Brewers, it's just a single lock. Upper Brewers is a double lock. Jones's Falls, 4 locks, and so on. And now you can see here where I finally hit Upper Rideau Lake, and this is the summit of the watershed system. And so from Rideau Lake, Upper Rideau Lake, going back to Lake Ontario, you're going that's downstream, and then also from Upper Rideau Lake to the Ottawa River, you're going downstream. So yeah, so for half my trip, I'll be going against the current, and then I'll be going with the current. And then, of course, coming back, when I come back to Perth, I will be going against the current all the way up through the Tay Canal here to Perth. So this is a very handy chart. It really highlights the whole Rideau Canal system, what you'll be going through. Other things you could put in your spreadsheet are calendars or whatever you would like. So my Kingston to Ottawa to Perth is a trip that I've already taken in 2017, and I have the videos that you could watch. I am planning a trip for the summer of 2018, late August probably, where I will be going from my home in Napanee all the way up to Georgian Bay. So this is basically, I'm very close to Lake Ontario, and Georgian Bay is actually part of Lake Huron, another Great Lake. And that will be a significant trip with a total of about 440 kilometers. And I'm thinking it'll take me 12 days to do that. So I've just started the planning for that trip, and I'm running through different scenarios here. You could see I'm being very aggressive. I'm planning to do 56.9 kilometers the first day at a speed of 8.5 kilometers an hour. Well, one of the modifications I'm planning to do for my boat this spring is to add another solar panel so that I will be getting more charging going into the batteries. So I'll see how that works out between now and when I'm ready to go on my trip, whether I have that modification done or not. If I haven't, then I will have to adjust this down to 7.5, maybe even less. Anyways, you could use this spreadsheet idea for, like I say, for any trip planning you want. I use this same idea for planning backcountry canoe trips into Algonquin Park. You could add a line item for portaging or whatever. It's a great tool. So between spreadsheet and Google Earth, I plan all my trips. I hope this was helpful.